Welcome back, everybody. This is the final of 3 parts in my series on solving linear equations. In the last couple of parts, we looked at how to solve those linear equations even when they don't necessarily look like linear equations at face value. But in this video, we're going to learn a little bit more vocab about linear equations and look at a couple of extreme examples. Let's get started. We need to start with some vocab here. An equation that is true, regardless of the values of its variables, is called an identity. And here's an example of an identity, that x plus 2 plus 5 is equal to x plus 7. If I simplify that left-hand side a little bit more, I get x plus 7 is x plus 7, and well, duh, regardless of what value of x you plug in, that's the same number on both sides of the equation. They're always going to be the same. That's an example of a silly identity. All of the problems we have looked at so far are called conditional equations. That means that it's not an identity, but it does have a solution still. However, there are some equations that don't have any real solutions, and we call those ones inconsistent. Here's an example of an inconsistent equation. There is no number that exists that is the same as when you add 1 to it. If it's a little bit easier, or if it helps to see this a little bit more clearly, if I were to subtract x from both sides, I would arrive at the conclusion that 0 is equal to 1, which is never true. So this equation is inconsistent. To get practice with these, I would like you to categorize each of the following, and we're going to do the first one all together. So this is a linear equation with some fractions in there. The first thing I want to do is clear those fractions. So I'm going to multiply both sides by 7 to clear the left-hand denominator. And I will get x plus 2 is equal to 5 minus, oops, pen gave out on me for a second there, 5 minus 7 times x plus 1, all over 5. I've still got a 5 to clear though, so I'm going to do that next. I'm going to multiply both sides. Oops, and I missed distributing there. 35. And now I'm going to multiply both sides by 5. On the left-hand side, I will get 5x plus 10 equals 5 times 35 is 175 minus 7 times x plus 1. And now I need to just simplify. Fully simplified on the left side, 5x plus 10. On the right side, I've got some distribution to do, and I get minus 7x minus 7. And I'm going to give myself a little bit more room here. Okay. Now, I can combine like terms again on the right-hand side to get 5x plus 10 is equal to 168 minus 7x. And now I need to move all of my x's over to one side. So I'm going to move my 7x over. And that'll cancel it out on the right-hand side. I'll be left with 12x plus 10 equals 168. And then I will subtract by 10 from both sides. Which will give me 12x equals 158. All in all, that will give me that x, oh, and here I'll use my color here, x equals 158 over 12, whatever that number happens to be. Oops, that was weird. Okay. Notice that this equation isn't an identity because it's not always true, but it does still have a solution. We call this conditional. We call this conditional. This is the kind of example we've already seen. Let's move on to some others. And again, I need to give myself a little bit more room on these problems. I would like you to pause the video here to see if you can do part B on your own. Aside from that little typo in the question that you hopefully caught in the edit, that being that I should have a plus here, not a minus in the problem, this is an identity because after much simplification, we end up getting 4x squared plus 36 is equal to 4x squared plus 36, and well, duh, regardless of what x value you plug in, that is the same number on both sides of the equation, so it's always going to be true. Though I'm sure you can probably figure it out through process of elimination, why don't you go ahead and give this one a try as well. Pause the video here and press play when you're ready. Now, maybe given my comment and given your sort of intuition behind process of elimination, you expected this to be inconsistent. But you still found the answer x equals 2. Now, I claim this is still inconsistent. But why? And as I'm writing, I want you to think about that. Why is this inconsistent? Well, take a look at our answer, x equals 2. If I were to plug that back in, I would cause division by 0. So x can't be 2. Sometimes, when using this process, we end up in this predicament. When this happens, we call x equals 2 an extraneous solution. An extraneous solution. We do arrive at the conclusion that x equals 2 should work, but it doesn't. And the ability to explain that phenomenon does require you to take a little bit of higher levels of math. So we're not going to discuss that just yet. But this is an important note to always check your answers. Always check your answers. This system is inconsistent. Sorry to throw you a curveball there at the end of the video, but that's going to wrap it up for this one and for our series on solving linear equations. Catch y'all in the next one.